Hello, we are going to discuss inclined planes. We are still looking at simple machines and friction. What we are going to do is very simple. We are going to define inclined planes. We shall find out how inclined planes simplify work. We shall look at the examples of inclined planes and the uses of inclined planes. Then we shall look at a few calculations on inclined planes. More complex calculations we shall do when we get back at school after COVID-19. For now, we shall just have some sample of calculations. So, we are going to start with the definitions. We shall look at two definitions. The first one is an inclined plane is a sloping surface joining a lower level to a higher level. If you don't want to use the word sloping, you use slanting. An inclined plane is a slanting surface joining two levels of different heights. So you either say it joins a lower level to a higher level, or it joins two levels of different heights. An inclined plane is a sloping surface joining two levels of different heights. How do inclined planes work? So this is the illustration of the inclined plane. We are joining this level to that level. We want to carry something from a lower level to a higher level. But then we need a slanting surface. So what do the inclined planes do? How do they simplify work? They increase the effort distance. This distance here is the load distance, and it is shorter than this one. But they increase the effort distance, reducing on the effort that you are applying. So we have got this vertical height. The vertical height is called the load distance. Then we have got the plane, the inclined plane, the plane here. The plane is the effort distance. Basically, inclined comes from the verb incline. To incline, the third meaning in your dictionary, the third meaning is to make something lean on something. So we get something and make it lean against that height, so that we can use that to move from the lower level to the higher level. So how do inclined planes work? They increase the effort distance and reduce the angle of inclination. This here is the angle of inclination. The greater this angle, the more the effort. The less this angle, the less the effort that you are going to apply. That means you'll even increase this distance here. So that is how they work. Examples of inclined planes: we have got a staircase, we have a ramp, winding road, and a ladder leaning against the wall. A staircase, those steps that lead us from one floor of a building to another one, that's an example of an inclined plane. A ramp is that piece of wood that you put on the surface of the road and onto a truck when you're loading things onto a truck or a lorry. That's called a ramp. Then we have a winding road. Winding roads are usually found in places that have those steep hills, and the winding road enables you to move from the bottom of the hill to the top of the hill. And then we have a ladder that is leaning against the wall. If the ladder is lying flat on the ground, it's not an inclined plane because it's not leaning. Because I said to incline means to lean, to make something lean against something. So a ladder must be leaning against either a wall or a tree, depending on where you want to move from the ground to somewhere. Maybe you want to go to a wall or to climb a tree or anything. So a ladder leaning against the wall. Uses of inclined planes. Uses of inclined planes, you have to be specific. Point out one and tell us what it does. A staircase enables us to move from one level of a building to another. A ramp enables us to load things onto a truck or a lorry. There are these vehicles called wide load that are used for carrying bulldozers from one place to another. They have their own ramp, which is built with them so that the bulldozer can move from the road up to the truck. Then a winding road, like the ones in Kabale or Kigezi, those ones there enable us to move from the bottom of the hill to the top of the hill. We are looking at the uses. A ladder enables you to climb a wall or a tree or a pole. Our friends in Umeme have their special ladders that they use for climbing their poles. Okay, those are the uses. Now we are going to have sample calculations, and yeah, that's the inclined plane. This side, one side is right angled. One side has a right angle. That is the side that has the vertical height, and the other side, which has the other angle, the other side, that side is the effort distance. So they are asking us to identify the load distance and the effort distance. The load distance, in this case, the side with the vertical height is the load distance. So the load distance is 5 meters, and the effort distance, the slanting side, is 10 meters. So load distance, effort distance. Then they are asking us to calculate the work done. We have already had numbers, sample numbers, where we are calculating work done. We said work is equal to force times distance, which is equal to, they want us to carry, these people carried this load of 300 kilograms from this level to that level. So we have to multiply the 300 kilograms by the load distance, because it was moved from this level to that level through that, but we are going to use 5 meters, which is 300 kilograms times 10, then times 5 meters. I hope you still remember why we multiply this by 10, because the load is in kilograms. We want to convert it to a force, which is in newtons. So, which is 3,000 newtons times 5 meters. Which will give us, this is 15,000. This is 15,000 Newton meters. Now, 1 Newton meter is equal to 1 joule. Therefore, 15,000 Newton meters is equal to 15,000 joules. My space is not enough, otherwise I'm supposed to show that. Then work out the force needed to raise the load. The force is equal to work done divided by effort distance, which will be 15,000 Newton meters divided by the effort distance, which is 10 meters. 10 meters. That one disappears and that disappears, so we are remaining with 1,500 newtons. That is the force that was used. Let's go ahead and work out the mechanical advantage in the diagram. There are two ways in which we find out the mechanical advantage on an inclined plane. Mechanical MA is equal to load over effort, which is the load is 3,000 newtons, which is 3,000 newtons divided by 1,500 newtons. That disappears, and we shall remain with 2. Mechanical advantage is the number of times a machine simplifies work, so our answer will be 2. Or alternatively, we can say mechanical advantage is equal to effort distance divided by load distance. Effort distance is 10 meters divided by 5 meters. 10 meters divided by 5 meters. That disappears. And then we shall remain 10 divided by 2, which will give us 2. So we got 2 here. Still we have got 2. There are no units for mechanical advantage. When we are dealing with mechanical advantage, there are no units because we are dividing the same forces. Then, this is our second example. Identify the machine in the diagram. So, that right angled side, it depends on where the way the examiner would want to arrange this. Sometimes the load could be the other side. Identify the machine in the diagram. It's called an inclined plane. Identify the load distance. Load distance is where we have the vertical height. Another one can draw it like that and say it's 3, then 15 meters. The side that has the right angle, that's the load distance. So the load distance in this case is 3 meters. effort distance is the side with the inclined plane. That is 15 meters. Calculate the work done to raise the load to the higher level. The load is raised from here to there. So if the load is raised from here to there, calculate the work done. Work is equal to force times distance, which is equal to 200 kg, 200 kg times 10. You know why we multiply by 10 first. Then times the load distance, which is 3 meters, which is 2,000 newtons times 3 meters, which will give us 2 times 3, 6,000 Newton meters. 1 Newton meter is equal to 1 joule. Therefore, we shall have 6,000 Newton meters, giving us 6,000 joules. The space was not enough. Work out the force needed to raise this load. Force is equal to work done divided by effort distance, which is 6,000 Newton meters. Another term to mean Newton meters is joules. 6,000 Newton meters divided by the effort distance, which is 15 meters. That one disappears, meters disappear, and then 60 divided by 15, 60 divided by 15 once by 54. So we shall have 400. We shall have 400 newtons. That is the force that was used. Calculate the, work out the mechanical advantage. MA is equal to load over effort, which is equal to, the load was 2,000, which is 2,000 divided by 2,000 newtons divided by 4. The effort is there, 400 newtons. N disappears. That disappears. 20 divided by 4 is equal to 5. 5 is the mechanical advantage. If we use the second method of mechanical advantage, we say MA is equal to ED, the effort distance over load distance, which is 15 divided by 3. 15 meters divided by 3 meters. 15 divided by 3 is equal to 5. So 5. Thank you for watching this video up to the very end. Don't forget to subscribe. Study 101 Uganda. Stay safe from COVID.